circuit breakers. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current and overload or short circuit. The circuit breaker is mainly designed for closing or opening of an electrical circuit, thus protects the electrical system from damage. Circuit breakers are made in varying sizes, from small devices that protect low current circuits or individual household appliance, up to large switchgear designed to protect high voltage circuits feeding entire city. MCB is very common example of circuit breaker. Let's understand its working. MCB is used to interrupt a circuit during overload and short circuit condition. It can be used as an alternative to fuses for domestic applications. Note: miniature circuit breakers are available in the following ratings: 6 ampere, 10 ampere, 16 ampere, 20 ampere, 25 ampere, up to 125 ampere. MCBs are available in single, 2, 3, and 4-pole versions. Construction of MCB. An MCB embodies complete enclosure in a molded insulating material. This provides mechanically strong and insulated housing. Incoming terminal. It is made up of electrolytic copper or silver alloy. This is where the incoming phase is fixed. Arc chute. Arc chute is a stack of mutually insulated parallel metal plates which divide and cool the arc. Bimetal strip. It is the part of thermal tripping arrangement around which a heater coil is wound to create heat depending on the flow of current. Magnetic coil. It is the part of thermal tripping arrangement where in case of short circuit strong magnetic field is produced in the coils. Copper braid. It connects the moving element with the static element. On/off switch. With this we can manually interrupt or turn on the electric circuit. Outgoing terminal. In this we connect outgoing phase from circuit breaker. Working of MCB. Under normal working conditions, circuit breaker work when we switch operator manually from position off to position on. Electric current carrying path shown below. First, current goes to incoming terminal. After that, current goes to contact point of moving. From contact point, the current passes through magnetic coil to bimetallic strip, and at last to the outgoing terminal, and this arrangement is in series. Under overload condition, the current through the bimetallic strip causes to raise in the temperature. The heat generated within the bimetallic is enough to cause deflection due to thermal expansion of metals. As a result, the contact gets separated. Types of circuit breakers. Miniature circuit breaker, molded case circuit breaker, MCB, motor protection circuit breakers, oil circuit breaker, air circuit breaker, vacuum circuit breaker, sulfur hexafluoride circuit breaker.